Hi, my name is Rahman Khan. I'm going to teach you how to use Minitab by taking you through a worked example from my book, Minitab Exercises for Green Belts. By the way, that's available on Amazon. I recommend you work along with the example by downloading the dataset from my website, RMK Six Sigma, and by the way, that's free. All the details are given below. Let's go when you're ready. This is the final video in a series of 3 videos on regression. The first video covered simple regression. The second video covered multiple regression, but with correlated predictors. And this video is going to cover multiple regression on its own. So if you want to work along with this example, you can download the datasets from my website, rmk6sigma.com. And if you want to do the full Greenbelt course on Minitab, you can go to my new website, think6sigma.com. Now, I might get complaints about this if I didn't tell you, but you can do the complete regression module for free at think6sigma.com at the moment. So that's about a 1 hour long video showing you a simple regression and multiple regression, giving you all the background to what multicollinearity is and how it affects our regression models. But it's only going to be there for a limited time. Exercise 9.06. You are supporting the national ski jumping team to prepare for the World Championships. Great Britain have not won any medals in this sport, so it's important you do a good job. It's your job to study the data from previous ski jumps by Ussum the Eagle and work out how to get a longer jump. To that end, you have collected data on Ussum's previous ski jumps and intend to conduct a multiple regression exercise and work out how to maximize the distance jumped. So you've worked out that the predictor columns are as follows. Angle is the angle of attack when in the air. Speed is the jump takeoff speed. Drag is the drag coefficient of the clothing including helmet. Ski set. Ussum has 3 pairs of skis which he uses for the jumps, so this is going to be a categorical predictor. As stated earlier, the task is to maximize the response variable distance, which is the distance jumped in meters. The data for the studies and worksheet ski jump. Analyze the data and report on the following. Number 1, demonstrate that there are no concerns with multicollinearity. If there are concerns, modify the predictors in the most appropriate way. Number 2, is there a significant relationship between at least one predictor and the response? Number 3, what is the strength for the relationship in terms of R squared? Number 4, which predictors are significant? Number 5, are there any significant interactions or quadratic terms? Number 6, show the regression equations. Number 7, can the study be validated through the residuals? Are there any issues? Number 8, what's the maximum jump distance that can be achieved? What are the suggested predictor levels to achieve this? And number 9, produce a contour plot marking the longest jump on the contour plot. So here's the data from worksheet ski jump in Minitab. Column C5 is the continuous response data, which is distance, which is the ski jump distance. C1, 2 and 3 are continuous predictors. Column C4, ski set, is a categorical variable depending on the ski set that is used. So there are 3 different ski sets that can be used. So we're reporting back to the Olympic team. They want us to do 9 things. First one of those is demonstrate that there are no concerns with multicollinearity in the model. If there are concerns, modify the predictors in the most appropriate way. So multicollinearity, as I said before, is kryptonite for regression models. So what we have to do, we have to check our continuous predictors to see if any of them are correlated. We do that by going to Stat, Basic Stats, Correlation, select our 3 continuous predictors, click OK, and we quickly see that there are no correlated predictors, so we should be okay with multicollinearity. We don't have to worry about that. So number 2, is there a significant relationship between at least one predictor and the response? To find that out, we need to run the regression model, so we'll go to Assistant, Regression, and we'll go to Multiple Regression. So our response is distance, enter in our predictors, and then our categorical predictor, ski set, click OK. Go to the decision bar at the top left of the summary report, and it says, is there a relationship between X and Y? And yes, there is. So there is a relationship between the response and at least one predictor. So we're on to number 3. What is the strength of the relationship in terms of R squared? So the R squared for this study is 39.99. So that's the amount of variation within the response that can be explained by changes in the predictors. Number 4, which predictors are significant? On the summary report, there are 2 ways to find out which predictors are significant. We can go to the comments section and see the significant predictors there. So angle is significant, speed is significant, ski set is significant, and then we have an angle quadratic, and we have an interaction between speed and ski set. That's interesting. And drag is not significant. And also within the main effects plots, we can see that angle and speed are significant, drag isn't significant because it's grayed out, and ski set is significant. Number 5, are there any significant interactions or quadratic terms? I've already given you the spoiler again, haven't I? So there was a significant interaction and there is a significant quadratic term. So angle of attack was a significant quadratic term. Number 6, show the regression equations. So I've enlarged them for you. Here are the regression equations. There's one for each level of categorical variable, being ski set. So there's one equation for each level of ski set. Number 7, can the study be validated through the residuals? Are there any issues? So let's have a look at the diagnostic report. There we see the residual versus the fitted values plot. Main thing to look at here is the number of large residuals. We have 7. Yeah, they are large residuals, but not too far out from the main body of residuals. So, okay, we can let that go because we would expect to have a number of large residuals anyway. I don't see any patterns indicating missing terms or unusual values, which is great. So I would validate this study based on the residuals. Number 8, what's the maximum jump distance that can be achieved? What are the suggested predictor levels to achieve this? The best way to look at maximum and minimum levels is to run the optimization model in regression. So we go back to the menu, click on optimize response. We have to put in our predictors and responses again. We enter distance first. We want to maximize the response, and we can put in our continuous predictors. We don't have to put in drag because it wasn't significant. And then we put in the categorical variable ski set. Click OK. So we go to the prediction and optimization report. So the maximum distance that can be achieved is 120.9. Bearing in mind the prediction interval is 75.7 to 166. So you could argue that you might be able to achieve 166 using these settings: an angle of 41.79 degrees, a speed of 31.99 and ski set 3. Produce a contour plot marking the longest jump on the contour plot. So let's produce the contour plot. We go to Stat, Regression, Contour Plot, and we'll have a look at Settings. And we want ski set 3, I believe. That was the best ski set for long distance jumps. Click OK. And OK again to produce the contour plot. Now we're going to put a flag onto the contour plot showing the longest ski jump distance. So we double click on the contour plot, maximize that, click on the little cross icon as the marker so we can then mark on where we think the longest jump is going to be. And if you look on the top left, you can see the distance, 117, 118. So you can see I need to be in that region that's the darkest, which is above 120. Now I need to find the region that gives me the longest ski jump. I had 129.11, but that's the one I've clicked on. So let's see if you can beat that at all. 120.909. Put in the comments below what you achieved. Okay, that little game ends this example and ends the series of 3 videos on regression. Thank you very much. I hope you enjoyed them. If you want to learn more about Minitab, you can subscribe to one of my many courses on my new website, think6sigma.com. You can also pick up a free 365-page Six Sigma Green Belt guide from my website, think6sigma.com. Let's continue to learn together. See you soon.